GM. Today we'll be starting with the module 1 of DevCamp, that is Intro to Ethereum. And don't worry, there are absolutely no prerequisites required to start this course. Let's look at what is Ethereum. So, the technical definition of Ethereum says that it's deterministic but practically unbounded state machine. But the practical definition is nothing that it is a decentralized computer that can execute smart contracts using blockchain, and it of course has its own native token called Ether. Now let's look at some properties of Ethereum and how Ethereum is compared to a normal computer. So of course Ethereum is slow and expensive as compared to the modern PCs. And when you think of a computer, you think of something physical, but that is not the case with Ethereum. The first properties of global singleton says that there is no physical presence of Ethereum, but of course it is decentralized. Hence the censorship resistant property says that there is no central authority. That means there is no central servers. It is not like AWS, that if you deploy your server on AWS you can turn the server down and then your app is not working. Nothing like that. It doesn't have a central server, so if you deploy something on Ethereum it will not be shut down and it will basically be there forever. So the other properties are very simple. It is accessible wherever there is internet, so anyone any point of time can access Ethereum, and it is multi-user. That means we can have practically infinite users on Ethereum. So let's look at why Ethereum. Why did we need a separate decentralized computer? First is very simple. We needed a decentralized computer to run decentralized applications. So basically, if your ID is banned on social media, what are you going to do? These sort of decisions are taken by a central authority and we don't have any ownership of it. So that is why we need decentralization and decentralized computers. So let's take a minute here and talk about the blockchain trilemma. So any blockchain when built is built on three pillars: scalability, security, and decentralization. Of course, when we try to achieve one, the other gets compromised, and that is why it is called a trilemma. In an ideal world, we would want a blockchain that is working at maximum capacity and provides maximum scalability, maximum security, and maximum decentralization. But Ethereum basically focuses on maximum decentralization. There are trade offs to focusing more on the one or the other thing. So since it focuses on decentralization, we get trustworthiness, but the trade-offs here are speed and the cost. So the accounts that are there or the contracts that are there are verifiable and auditable. That means that smart contracts are immutable, and once deployed you cannot change it. So unlike we deploy stuff on Vercel and you can change the deployment, even you can delete the deployment, but that is not the case on Ethereum. That is when the auditableness comes in. Your smart contracts are auditable also, and since it cannot be changed, it is sort of requested that before deploying anything, please test it, please check it, so that you're deploying the correct version of it. Now let's look at Ethereum versus Bitcoin. So we are not maxis of one over the another. We are lover of all blockchains. But for learning purposes, we need to understand how both of these chains are so different from each other and how they work. So Ethereum basically uses a Turing complete language. It means that it can perform any computation given enough time and resources. It can do loops, it can do recursion, it can do conditional statements, and it can do all the complex stuff that you can think of. But Bitcoin uses restricted script language. So it has a lot of limitations and it gives simple functionality, and that is done to enhance security. It doesn't have any option to compute loops in it, and that is there to prevent infinite loops. Now let's come at proof of stake versus proof of work. So, whatever is there on blockchain, how do we verify if that is correct or not? There are certain consensus mechanisms used in blockchain networks to validate these transactions. Two of those consensus mechanisms are proof of stake and proof of work. So, proof of stake, it basically means that we choose, like the validators are chosen to create new blocks based on the number of coins they hold and are willing to stake as collateral. We'll learn about proof of stake in the later lectures, but it is basically more energy efficient than proof of work, and rewards are proportional to the staked amount, reducing the need of a lot of hardware intensive work. So, proof of work, unlike proof of stake, it requires a lot of hardware heavy stuff and a lot of energy. It is not that energy efficient, but basically, miners need to solve complex mathematical puzzles using their computational power. The first one to solve it adds a new block to the blockchain and is rewarded with some Bitcoin or the cryptocurrency. This method, proof of work, as I said, is very energy incentive and it requires a lot of hardware. Let's discuss the account model and the UTXO model. So the account model that Ethereum utilizes tracks can be like tracks balances in accounts. It can use like to directly update the sender and receivers their balances for each transactions, and can be of two types of Ethereum. Like Ethereum basically has two accounts, externally owned and the contract accounts. So externally owned accounts, EOAs, are there, and the contracted accounts are nothing but just the smart contract accounts. Now the UTXO model tracks the unspent outputs from the previous transactions and they use them as inputs for new transactions. So that is how both works. And this is it. In the next lecture, we'll be diving more details into the proof of stake and then we'll take the course ahead. Hope this was helpful. Thank you a lot for coming.